Hello students, we are going through real number and today we will learn an important theorem of real number, that is fundamental theorem of arithmetic. Completely new thing for standard 10. Though it is not very difficult, I will first make you understand what is this theorem all about and what is the statement of the theorem. You must know the statement of Euclid's division lemma. You must know fundamental theorem of arithmetic. Now, fundamental theorem of arithmetic is simply, it says, any composite number can be decomposed as the product of its primes, and the prime factors of the composite number is unique, irrespective of the orders in which they are placed. Now see, any composite number, we know that numbers are of two types. One is prime numbers and the second one is composite number. Now what is prime number? The number which is divisible by itself and 1, that is called prime number. And the number which is divisible by any digit other than itself and 1 is called the composite number. For example, 3 is prime because 3 is divided only by 3 and 1. On the other hand, 6 is a composite number because 6 can be divided by 1, can be divided by 6, can be divided by 2, can be divided by 3. So any number which can be divided by any number other than itself and 1 is called a composite number. The theorem states any composite number, it can be decomposed, means it can be splitted. It can be splitted as the product of its primes. For example we are taking an example of 10. 10 is a composite number. We can split it as 2 into 5. By prime factorization, we can find the value of 10 as 2 into 5. So now you see this number, composite number 10 is divisible by 1, it is divisible by 2, it is divisible by 5 and divisible by 10. So now 10 is equal to 2 into 5. Any composite number can be decomposed or splitted as the product of its primes. We have decomposed, we have split it as the product of its primes. And this prime, it will be factorization. And this prime factorization of the composite number is unique. See, this one is unique. 10 cannot be splitted in some other way. It can be irrespective of the order in which they are placed. You can write it as 5 into 2. Where you are writing what is the order, immaterial. But the prime factors of 10 is always 2 and 5 and it is unique. You cannot have any third factor of 10. We are taking another number 6, 2 into 3. 6 is a composite number. It can be splitted as the product of the 2 and 3, the by prime factorization method. And the prime factorization of this composite number 6 is unique. This is unique. 6 will have always two factors, that is 2 and 3. You can write 2 and 3, you can write 3 into 2. In whatever order you write, its prime factors are always 2 and 3. So this is all about your fundamental theorem of arithmetic. This statement you have to go through, you have to cram. Now, on the basis of this theorem, we will start the exercise 1.2. See, first one, very easy. Express each number as the product of its prime factors. Suppose we are taking 156. Question number 2. One question I am solving for you. Rest you will do 156. Simply product of its prime. What is the method? Prime factorization. 2. So what we are finding, this 156 can be written as 2 into 2 into 3 into 13, or we can write it 2 square into 3 into 15. And this prime factorization of the composite number 156 is unique. Whether you write 13 first or 3 first, 2 square last, immaterial. So in this way, there are 5 questions are given. You can solve by yourself. Question number 2. Find the LCM and HCF of the following numbers and verify that LCM into HCF is the product of the two numbers. An interesting property you have learned in your earlier class also. Let me recap once again. Product of any two numbers is equal to product of their HCF and LCM. Now see, one question from here we will do, that is first of question number 2, 26 and 91. See, 26, find out the prime factors, 2, 13. So we can write 26 as 2 into 13, 91. 91 can be written as 7 into 13. So this composite number 26 and this composite number 91 is splitted. Now what we have to do? We have to find out the HCF, highest common factor. After doing this prime factorization of 26 and 91, we will find out the HCF. HCF is the factor which is common in both, that is 13. 13 is the HCF. Now LCM of 26 and 91 is equal to the common factor and the uncommon factor left. 13 into 2 into 7. 13 will be taken one time because it is a common factor, into 2 into 7. That will be 26 into 7. 182 is the LCM. So HCF is 13 and LCM is 182. So product of the numbers will be 26 into 91. Just multiply 91 into 26. 2366. It is 2366, product of the numbers, and product of their HCF and LCM. What is the HCF we have got? It is 13. What is the LCM we have got? 182. So again 182 into 13. 2366. Therefore, the product of the two numbers is equal to product of their HCF and LCM that we have shown. Fine, we have calculated HCF and LCM by prime factorization method, and then we have shown that the product of their HCF and LCM is equal to product of the number itself. Now come to question number 3. Yes, dear students, now come to question number 3. Find the LCM and HCF of the following integers by the prime factorization method. As I have explained how to find out the HCF and LCM, and the method that I am using over here, that is known as the prime factorization method. By that method you can solve question number 3. Come to question number 4. Question number 3 can easily be solved if you have understood. And remember, this method is known as the prime factorization method. Question number 4. HCF of two numbers given HCF of 306 and 657 is equal to 9. You are required to find LCM of 306 and 657. Simply, the application of this product of the two numbers is equal to product of their HCF and LCM. Simply, you can write LCM of 306, 657 is equal to product of the two numbers 657 divided by their HCF. That means that what is the formula? Product of the two numbers divided by HCF. You will do it and you will get the value of LCM. LCM can be calculated simply by using this very formula. Property. Product of any two numbers is equal to product of their HCF and LCM. Now question number 5 we are coming to. Check whether 6 to the power n can end with the digit 0 for any natural n. 6 to the power n. Whether 6 to the power n can end. See, students, go through NCERT book and see the question and read the question again and again in order to understand what it says. Check whether 6 to the power n can end with the digit 0 for any natural n. Let me explain the thing. 6 to the power n, say 6 to the power 2, 6 into 2, 6 into 6, 36. N is a natural number. N belongs to natural number. N is n. N is a natural number. It says the expansion of 6 to the power n cannot end with the digit 0. Here, a very important thing, just you try to understand, any number, if it ends with 0, it must have two factors, 2 and 5. See, the smallest number that ends with 0, 10. The factors are 2 into 5. 20, 0 ending number, it will have the factors 2 into 2 into 5. Now 30, if I say 2 into 3 into 5. So what we are finding? If a number ends with the digit 0, it must have 5 and 2 as its factor. 5 and 2 as its factor. Now 6 to the power n is the question. The prime factors of 6 is made up of 2 into 3. It does not contain 5. The prime factors of 6 is made up of 2 into 3 and it does not contain 5. And this prime factorization is unique according to the fundamental theorem of arithmetic, and hence 6 to the power n, where n belongs to a natural number, can never end with the digit 0. Hope you have understood. I told you that any number, if it ends with the digit 0, it must have two factors, compulsorily 2 and 5, apart from any other number. Now 6 to the power n, the base is 6. N is a natural number. The prime factors of 6, 2 and 3. 2 is there, but 5 is absent. Since 5 is absent, therefore the expansion of 6 to the power n can never end with the digit 0. So this is the clarification. You have to give the explanation, what you have understood, what I mean to make you understand, that you have to just write. The prime factors of 6 consists of 2 and 3, and it does not contain 5. No number, every number which ends with the digit 0 must have 2 and 5 as its prime factors. Since 5 is missing, therefore 6 to the power n, where n belongs to a natural number, can never end with the digit 0. Next one, question number 6, I will explain. Question number 6. Explain why 7 into 11 into 13 plus 13. One of the two questions I have taken. And another question is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a this is a composite number and this is a composite number. Why? You have to say. The first one I am explaining, the second one you yourself will do on the light of the first. See, there are two things, two components. 7 into 11 into 13, 1, and the second one is 13. They are separated by the plus sign. We will take 13 as common. We will get 7 into 11 plus 1. So what we are finding, that this very number which is given question consists of a factor 13 other than itself and 1. Any number is always divisible by itself and 1. So this very number is always also divisible by itself and 1. But apart from itself and 1, this given number is always also divisible by a third number 13, and hence this number is a composite number. Similarly, what we will take here, this one is one term and 5 is the second term. What we will take as common? We will take 5 as common. We are left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. Enough. You have not to multiply it. You will simply say, thus the given number, this one, has a factor 5 other than itself and 1, and hence this number is a composite number, using the fundamental theorem of arithmetic. And the last one, again, this question needs an explanation, and let me read out the question and explain it. There is a circular path around a sports field. See, a sports field, a circular sports field is there. That is the last question of this exercise. A circular field. And Sonia is here. Sonia takes 18 minutes. In 18 minutes, Sonia takes 18 minutes to drive one round of the field. In order to complete one revolution, Sonia takes 18 minutes, while Ravi takes 12 minutes. 12 minutes. Ravi's 12 minutes, Sonia's 18. If Sonia starts from this very point, she will take 18 minutes to reach back to the same point, and if Ravi starts from this point, he will take 12 minutes to start to the initial point. This is the question. Suppose they both start at the same time and at the same point and same time, and go in the same direction. Both started from here at the same time. From the point of A, they both started. Now Ravi is faster. Very clearly you will find from the question that Ravi only takes 12 minutes to complete the revolution, whereas Sonia takes 18 minutes. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? At this very point, I would like to tell one thing. Sonia takes 18 minutes. Ravi takes 12 minutes. At a particular period of time, they start moving in the same direction together with their respective speed. Now, after how much time they will meet once again? This is the very question. So, either it will be HCF or LCM. This is the often the students face this problem whether to find out HCF or LCM. Remember, 18 minutes Sonia takes, 12 minutes Ravi takes. If we take the LCM of these two numbers, it will be greater than these two numbers. And if we take the LCM of these two numbers, it will be smaller. Smaller means say 10 minutes. Definitely, after 10 minutes they cannot meet. After 5 minutes they cannot meet because they have started and they are going on the circular path. So HCF will not be the required answer. They cannot meet at a time which is smaller than 18 minutes as well as 12 minutes. So if the smaller is curtailed, we are left with the LCM. And LCM of these two numbers, 18 minutes and 12 minutes, will be the required answer. So the time at which they meet again is the LCM of 18 and 12. So find it out. 2, 9, 6, 3, 2, 2. 3, 3, 2. Now the required LCM of 18 and 12 is equal to 2 into 3 into 3 into 2. 36 minutes. So after 36 minutes, they will meet again. Hope students, you have understood all the problems that I have discussed from this exercise. So you yourself try to do the sums, solve the sums you yourself personally, and just see whether you have understood or not, whether you are in a position to solve the questions or not. Till then, goodbye.